Welcome. In this session, we will determine the concavity for another one of the functions we have been working with, namely x power 4/3 minus 8x power 1/3. So first I need to find the second derivative. Let's start with the first derivative. It's just the power rule term by term. I get 4/3 x to the power 1/3 minus 8/3 x to the power negative 2/3. Second derivative similarly is done using the power rule. For the first term, I get 4/3 times 1/3 x to the power 1/3 minus 1. 1/3 minus 1 is negative 2/3. Minus 8/3 times negative 2/3 x to the power negative 2/3 minus 1. Negative 2/3 minus 1 is negative 5/3. Since I need to do the sign chart for this function, the second derivative, I'm going to simplify this a little bit. Do the multiplication in the coefficients and write the negative exponents instead using fraction. And then add the two fractions by putting them over a common denominator. The least common denominator will be 9x to the power 5/3. In the first fraction, I have 9x to the 2/3. So to get to the common denominator, I need to multiply the denominator by x to the 3/3. So I should also multiply the numerator by x to the 3/3. The second fraction, I already have the common denominator. Now if I combine the two fractions, the numerator will be 4x plus 16, or if I factor out the 4, I get 4 times the quantity x plus 4. So the second derivative is 0 when x plus 4 is 0, or that is when x is negative 4. Second derivative is not defined when x is 0, or more precisely, the original function doesn't have a second derivative at 0. Or equivalently, the expression giving y double prime is discontinuous at 0. Only numbers at which y double prime can change sign are negative 4 and 0. So the intervals in which it has a fixed sign, unchanging sign, we start at the extreme left of the domain, so that's negative infinity. First number we hit in this list is negative 4, and then starting at negative 4 we can go till 0. After 0, y double prime is defined and continuous everywhere. So last interval is 0 to infinity. I will do the sign chart by using test values. I'm just picking numbers which are perfect cubes because the denominator has a cube root. You can put these numbers in and look at the sign. Negative 8 plus 4 is negative. Cube root of negative 8 is negative 2. Its fifth power is also negative. So the fraction is negative over negative, which is positive. At negative 1, it will be positive over negative. Y double prime is negative. At 1, y double prime is positive over positive, that's positive. The problem asked where this function is concave down. That's where the second derivative is negative. That is in the second interval negative 4 to 0. So that's where the original function is concave down.